Hello learners, welcome back to our Grade 12 Geography revision. Today we are revising mid-latitude cyclones using a satellite image question, exactly like what you see in the final exam. This lesson is very important because satellite image questions are easy marks if you know how to read them properly. So please pause the video and look carefully at the image on the screen, and let's revise it together. Look at the satellite image on your screen. You can see a large spiral or comma-shaped cloud pattern south of South Africa. This shape immediately tells us that this is a mid-latitude cyclone. You must always remember mid-latitude cyclones form between 30 degrees and 60 degrees latitude. They develop along the polar front and they are low pressure systems. Here is a tip. If you see a spiral cloud shape on a satellite image, always think of a mid-latitude cyclone. Now look at the area labeled cold front. Notice the clouds. They are thick, they are bright white. They form a narrow band. This tells us that this is a cold front. Cold front occurs when cold air pushes underneath warm air. Warm air rises rapidly and this forms cumulonimbus clouds. Weather at the cold front includes heavy rain, strong winds, a sudden drop in temperature. So in exam, cold fronts are identified by a dense cloud band and heavy rainfall. Now look at the area labeled warm front. You will notice the clouds are spread out. They are thin and layered. The cloud band is much wider. This tells us that this is a warm front. Warm front form when warm air gently rises over cold air. Weather at the warm front is light to moderate rain. We have overcast skies and a gradual increase in temperature. Warm front brings gentle, long-lasting rain, not heavy showers. Now let's look at point A. Point A is found between a cold front and a warm front. This area is known as the warm sector. In the warm sector, the warm air is trapped between the two fronts. Weather is usually mild, it is humid and cloudy. Now let's look at point B. Point B is located over the southern part of South Africa. This is an area being affected by the approaching cold front. Weather condition at B includes increasing cloud cover. There is strong winds and heavy rainfall. Colder temperatures after the front passes. This explains why the Western Cape receives winter rainfall. Mid-latitude cyclone move from west to east due to the westerly wind belt. On this image, the system is clearly moving towards South Africa from the Atlantic Ocean. So always mention the westerlies when you are asked about the movement. Question 1.3.1. A is a low or high pressure. Let us focus on point A. In a mid-latitude cyclone, the center is always a low pressure. Air rises. Rising air causes clouds and rain. At point A, we see thick clouds cover. We see fronts attached. This tells us that the air is rising. So the answer is low pressure. So you must not explain anything when the question says choose one. Question 1.3.2. Give evidence from the satellite image for your answer. Now the examiner wants the proof from the picture, not the theory. Look carefully at the satellite image. You can see clouds rotating clockwise. You can see cold and warm fronts. You can see thick clouds formation. All these are signs of rising air, condensation, and low pressure. You can say clockwise circulation of clouds. You can also say presence of cold and warm fronts. You can also say condensation and cloud formation. Question 1.3.3. Describe the rainfall associated with the warm front. 2 marks. Warm fronts behave very differently from cold fronts. At a warm front, warm air rises slowly. The slope is gentle and the clouds are layered. This produces long-lasting rain, gentle rain, not heavy thunderstorms. So your answer should be light rainfall, or you can say continuous rainfall. Question 1.3.4. Give a reason why the interior of South Africa experiences clear skies. 2 marks. This question links synoptic weather to South Africa's interior. The interior is affected by the Kalahari high pressure system. High pressure means air is sinking. Sinking air warms. Warm air does not condense, no clouds form. That is why skies are clear. Your answer should be the interior is dominated by sinking air from the Kalahari high. You can also talk about the strong subsidence prevents clouds formation. You can also say the area lies in the warm sector of the cyclone. So if you see clear skies, always think of high pressure plus sinking air. Question 1.3.5. Explain how the approaching cloud front changes the cloud cover in the winds at area B. This is the most important question. The examiner says you must talk about both cloud cover and wind. Let's start with the cloud cover. As the cold front approaches area B, cold air forces warm moist air to rise. Rising air cools, condensation increases, cloud cover increases, and thick clouds form. Overcast skies develop and cumulonimbus clouds may form. Now about wind. As the front moves closer, pressure gradient becomes steeper. Wind becomes stronger and gusty. Wind direction changes due to the clockwise circulation. Wind backs because of the system is moving eastwards. So here can be your paragraph answer. As the cold front approaches area B, warm moist air is forced to rise rapidly, resulting in increased uplifting. The rising air cools and condenses, leading to an increase in cloud cover and overcast condition. Thick cumulonimbus clouds may develop. At the same time, the pressure gradient becomes steeper, causing stronger and gusty winds. The clockwise circulation of the mid-latitude cyclone changes the wind direction, and backing of wind occurs as the system moves eastwards.